we have a quiz first thing, showing some of the things that we have to play with inside our module. Oh, look, there's Harold. How exciting. Okay, so these are the digital manipulatives just like we had before. Okay, we're almost there. I think we're only missing one person. All right, if you don't have, you don't like the digital ones, you can always rip up paper, make your baggie, make your little pieces of paper. This one's red. You just write on it. All right. The other thing to know in the module is that there is a discussion down at the bottom. It says here is a blank decision tree. You will see this. We're going to be working with this in the lesson. It might help you to have this. It's more of a thought thing. Okay, and the last one is the discussion right here. That is going to be the first thing we're going into once we get into the module. All right, so this is our quiz right here, variables quiz. Is everybody ready? Does anybody have a problem? I'm going to give you your password for your quiz. You have 10 minutes. There are only 3 answers, 3 questions. It is not that difficult. The password is snowing. What we wish it was doing so we could have a little winter wonderland. Please let me know if you are having difficulty getting into your quiz. Okay? So right now it is 1:44. We will be done at 1:54. Or when everyone is done. Nobody seems to have questions. I'm going to stop sharing so I can monitor. I can see how many people are taking it. My numbers have been low. So I'm only seeing 22 people in here. Oh, Anna, goodness. Anna, we are taking our quiz. Let me quickly show you where this is in the module. All right. So Anna, you just got in. Let me show you in the module. We're taking our quiz. You have 10 minutes. We just started. Okay, the quiz is right here at the top of the module. The password is snowing, S-N-O-W-I-N-G. I will put it in the chat again. You have 10 minutes. So we have until 1:56. I will be checking to see if people get done earlier, which sometimes they do. I am not seeing everyone in the quiz. If you are in class and you do not take your quiz, I am not supposed to allow you to retake it. So please take your quiz. This is not really difficult. You guys can do this. I know it. All right. Guys, I'm not showing a lot of people in here. I should have 33 people in here, but right now I'm only showing 16. And let me check, see if everyone is finished. Okay, I think everyone is done. Anybody not done? Anybody not finished with their test, with their quiz? Okay, let's get back to the fun part. We get our presentation up. We will be rocking. All right, my team. We have something new today. Make sure, not being muted or anything. Put this over on the other side. Okay, today is Monday, the 14th of December. We have completed our quiz. We are looking at Unit 4, Lesson 5, Conditionals. Okay? Our quiz is what is due. Don't worry, it's already been submitted. The exciting thing is there is no homework because it's interim and we don't want another grade for you. You'll be able to use appropriate vocabulary, evaluate expressions, and trace simple programs to describe Boolean expressions, conditional statements, and logical operators. Okay? Do not be dismayed that you do not know what Boolean expressions, conditional statements, and logical operators are. All will be made clear. Okay? Unit 4, Lesson 5, conditionals. So we're out of variables, and now we're working on conditionals. Somehow my computer keeps linking to my stereo, which gets a little weird. Okay, we were going to do something with the Nearpod, but we've given up. Imagine you want to make a decision about what to wear to an event. Name 2 pieces of information you'd want to help you make your decision. How would you use them in your decision? Okay, so you're just going to go to that discussion. For anyone who got here at the end or after class, if you just look in the module, there is a discussion right here at the bottom. Discussion, choice of clothes. Just hang on. I need to start sharing again to show you. Okay, so just choice of clothes discussion down here. You have 2 minutes, so 1:57. We're not going to work with this right now, but we will at the end. So put your 2 pieces of information you need to decide what clothes you'll wear to a party and how you would use them to make your choice. Okay? Okay. So while you're doing that, I'm just going to go over, ideally you need manipulatives today. It is relatively easy to follow along with the lecture, but just something we figured out was even these manipulatives in the actual lecture can be used. See, I can move the baggie, I can name, I can put text on here. So true, I can put that in my, come on. I can grab that and put it in my baggie. That's the same as the digital ones. If you don't have any, you can always rip sheets of paper in half to make your baggie, and then rip some smaller pieces to be your Post-its. It just helps you to have these visuals, to have this idea of how a variable works. All right, I have mine, so I will present and you can just watch if that's what makes sense to you. Okay, is everybody done with the discussion? Anybody not done with their discussion?
I have like 1 more minute.
Sure. It doesn't have to be too long, don't worry. Only one person is actually going to go through it. Okay, let me just, you already know this. We did this in the last lecture. So information can be stored as numbers made of digits 0 through 9. No quotes, and they go on a yellow sticky. Strings are made up of any characters on a keyboard inside the double quotes. They go on a red sticky. Technically, we're never using a string today, but don't worry about that. Information can also be stored as a Boolean. Boolean true or false blue sticky, okay? So we are going to use blue stickies to make true or false. Again, if you just write on the white paper blue, bang, you've got a blue sticky. Even if you write blue on a yellow sticky, you've got a blue sticky. So see what you can. Write true on one sticky note and false on another. Here's the exciting question. I've only had one student really do this. How about you turn on your camera and show me your stickies? Show me your false or your true. Anybody got one? And it sounded like somebody turned on their camera, but they didn't. No, nobody's buying into this. You're just like my dog. My dog knows when you have an ulterior motive, like you're trying to put his, flea and tick stuff on her. Okay, so allow me to demonstrate. Look, I have true and false. All right, these are going to help us today. Today we are going to be going through Boolean expressions and how to evaluate, okay? So since you guys aren't helping me, I'm going to the fabulous spinner. Eduardo, 3 is less than 8 evaluates to what? True or false?
True.
True. 3 is less than 8. Beautiful. You're brilliant. Okay. Less than is a comparison operator. It's a clue that we need to stop and evaluate for a Boolean value. Comparison operators, you already know from math. These are less than, greater than, equal to, less than or equal to, greater than or equal to, or not equal to. For our purposes, these look a little different than what you're used to in your math class. So less than and greater than are classic. That's great. Equal to is not the equal sign, what I refer to as 2 parallel lines, because 2 parallel lines do not mean equals in our coding world. They mean put this value in the variable. The 2 parallel lines mean put this value in this variable. I am putting this value in this variable. I am throwing out whatever was in there, and I am putting it in when I see an equal sign. The double equal sign, 2 equal signs, is the mathematical operator equal to in our computer programming world. Less than and an equal sign is less than or equal to, greater than with an equal sign after it is greater than or equal to, and an exclamation point with an equal sign is not equal to. Okay? So each side of the comparison operator must be reduced to 1 sticky note before we can compare. So Audrey Wang, could you evaluate the left side of this equation so that we can evaluate the equation with the operator?
I'm not sure what you're talking about right now. I don't.
Okay. So are you seeing my screen?
Yeah, I see it.
Okay. When we were dealing with variables, what did we always have to do before we could evaluate something?
We have to find out what's when you do the baggies, what's in the variable thing.
Well, you need to reduce both sides to 1 number. Okay. So all I'm asking you to, in terms of evaluating this, is what does 3 plus 6 equal?
9.
9. Okay. So now that we've reduced this to 9 is less than 8, we can evaluate our Boolean expression. So with 9 is less than 8, what would that evaluate to in our Boolean true-false world?
It'll be false.
That would be false, correct. Beautiful job, thank you. Okay, this is for everyone. All right, let's look at these and go through. These are relatively easy, but just like variables, you need to evaluate both sides first to get it down to one sticky before you can check the Boolean expression, whether it's valid. So our first one, can anyone tell me, do you want to put it in the chat? Number 1, is this true or false? Let me see something in the chat. 6 minus 3 is less than 4 plus 1. You should have your answer by now. Can someone put an answer in the chat, please? Is 6 minus 3 less than 4 plus 1? Ah, look, we've got competing. We have true, false, true. All right, let's figure it out. So 6 minus 3 is 3. 4 plus 1 is 5. 3 is less than 5. So thus, that would be true. All right. 12 divided by 6 is greater than 3 minus 0. Is this one true or false? 12 divided by 6 greater than 3 minus 0. Guys, I saw you in your test. Some of you were doing the test in 30 seconds. False, false, false. 2, so 12 divided by 6 is 2. 3 minus 0 is 3. 2 is greater than 3. False. All right. So in the next one, it's a little different. We've got parentheses. Again, standard math operator procedures take place. You do whatever is in the parentheses first, okay? So this is going to be 7 minus 3 times 3 is less than or equal to 10. How does this evaluate? Is that true or false? 7 minus 3 times 3 is less than or equal to 10. Ah, we have a vote for false. 7 minus 3 is, oh, that's interesting. Why is it, oh, 7 minus 3 should be 4, not, oh, it's evaluating the whole thing. It's not giving us the 4, but this should be 4 times 3 is 12 equals 10, is less than 10. Okay, so 12 is less than 10. That is not right. That is false. 9 plus 5 equals 4 plus 10. What do we think about this one? 9 plus 5 equals 4 plus 10. Come on, it's simple math. Is 9 plus 5 equal to 4 plus 10? True, true, true. Yes, 14 is equal to 14. Okay, now it gets a little more exciting. Any values, any of the values in an expression can be a variable, right? Because a variable can have a value. So if I have not boo, I need lives. Where are my lives? There's a lives. Lives is 5. Not my dogs. I need a score. Where is my score? There, score is 10. All right, so I have lives is 5, score is 10. How do we evaluate this? Do you remember? We don't think about the variable. So it's not my variable lives that I am going to add to 4. It is the value in my variable lives, right? So I am just going to add 5 to 5. If I could find a 5 to show you, I'm going to make myself a 5. So 5, right? So it's going to be lives is 5 plus 4. Score is what? Where is score? What's the number that I'm going to be using here? Can anyone tell me? Put it in the chat. If lives is 5, what is score? Right? We're not finding it. It's 10. All right. So 5, 10, 5 plus 4 is less than 10 minus 1. What will this evaluate to? You can unmute or you can put it in the chat. 5 plus 4 is less than 10 minus 1. Anybody? False. Yay. 9 is less than 9. False. It would need an equal sign with it to make it less than or equal to, and then it would have worked. All right. Note that any expression can be evaluated for true or false. Any expression that can be evaluated for true or false is known as a Boolean expression. A Boolean expression is evaluated true or false in our computing world. All right, decision time. This is getting a little more complex. Can I go to the movies? I'm allowed to if it's before 8 o'clock. What information do I need to know? What variable do I need to create? Ryan Poulin, can you tell me what piece of information do I need to know to be able to determine, can I go to the movies? I'm allowed to if it's before 8 o'clock. It says create a baggy variable to store that information. What am I going to call it? Ryan? Any ideas? Again, I'm not worried whether you get it right or wrong. I just want you to try because some of this stuff is a little intuitive. This is all very new to everyone. Okay? Kareem Ahmed, what do you think I'm making a baggie called? What is my variable that I need?
For the movies,
Yeah.
uh,
What's the thing that's going to change to determine whether I get to go to my movie or not?
the time.
The time. Perfect. All right. So here we go. Can I see? We've got our variable time at the top. Strangely, it looks like a pink Post-it in there. Technically, it's yellow. So let's see. Somewhere around here, I have time. There, look. I have time, and it has a blank variable in there. I don't know what time is yet. Then I have my Boolean expression. Is time less than 8? If time is less than 8, then it will evaluate to true, and I can go to the movies. As long as the movie starts before 8, I get to go. If it's not, I can't go. All right. So Kareem, I'm going to ask you, if it's 9 o'clock, can I go to the movies?
No.
No. So it's just the simple, time is 9. I take my 9 and I put it in my equation instead of the variable. 9 is less than 8. That certainly seems false to me. I can't go to the movies. All right? Great job, Kareem. Have I won the game? If I have, if my score times my lives is greater than 10. All right? So what do we think our variables are going to be? Liam Klein, can you tell me what are the variables I need to create baggies for here?
You broke up a little. Can you say the question again?
Sure. It's just the bottom. So have I won the game is our question. I have if my score times my lives is greater than 10. So what are the two variables we are going to need to create our tree and figure out the right answer?
Your score and your lives.
Absolutely. Very straightforward. Perfect. Okay. So I need my score and I need my lives, right? You can ignore what's in them. So here we are. I've got my two variables, score and lives. Here is my Boolean expression, exactly what it said. I have won the game if my score times my lives is greater than 10. So score times lives greater than 10 evaluates true. Yes.
Mr. Swift, I don't know if it's just for me, but I see you're still sharing the Google Slides. Like, I don't see like the code.
There is no code. What code?
Well, I mean, for
Hang on,
me, your
wait.
screen is stuck on Conditionals Explorer.
Okay, I hate to say I've heard that before. I don't know why this happens. Thank you. Let's see if this fixes it for us. Thank you. I'm sorry if this was not as clear as it should be. Okay, are you seeing the screen now? It should be, have I won the game?
Yes, I can see it.
Okay, so let me just quickly go backwards. Hang on. So this is all it was when we did it before. Can I go to the movies? Time 9 is less than 8, evaluates to false. Okay, so here we are. We're right on. Alex Selden, can you walk us through test 1? What if score is 3 and lives is 3? How does this evaluate?
So, sorry. Test 1, if your score is 3 and your lives is 3, 3 times 3 is 9. And 9 is not greater than 10, which means it would be false.
Perfect. You are the man. Thank you so much. Ethan Z, what about test 2? Ethan? He's having mic problems. Oh, look, my phone's now attached to my speakers. Nikolai, can you do test 2 for me?
Yeah, so it's false.
All right. And what about test 3?
It's also false.
Perfect. And it's going to be minus 10 is greater than 10. Okay. So we never win our game. Very sad. But here's a fun one. Is my dog older than me if his age is converted to human years? 7 years equals 1 human, 7 dog years equals 1 human year. Okay. Dakota Duckett, can you tell me what are the 2 variables we need for this? Dakota?
Would it be like your dog and then like the dog years and then human years?
Right. You need the age of your dog and you need your age. That's all. We know that dog years are 7 years per 1 human year. So we just need our dog and our human. So we've got my age and dog age, or just dog and me, whatever makes sense to you. All right. So then we're going to take my dog's age and multiply it by 7 and ask, is that greater than my age? Okay, so let me try this. Julie Fawn, if my dog is 5 years old and I am 25 years old, how does this evaluate? So the
Your
dog
dog
is
would
5
be-
years old and
Mhm.
I'm 25.
So your dog is older than you because that would convert to 35 in human years.
Right. It would just be 5 times 7, and my age is 25, so 35 is greater than 25. My dog is older than me. She seems so young. All right, that is great work. Okay, what if my decision requires several steps? Can I adopt a cat? I can if I have $40 and I am over 14 years old. That golden year of responsibility. Okay, so how are we going to do this? What information do we need? What variables are we going to create? Let's see. Madison Yu, what do you think we need to know? What are our variables here?
Sorry, could you say that again?
Just what are the variables we need to create baggies for?
Just like
I can
random
adopt a
name.
cat if I have $40 and I'm over 14 years old. So what numbers are moving?
40 and 14.
Correct. So that's another good way to think about it. Anything that is moving is going to be a variable. Okay. So we are going to need money and age, right? I need to know how much money I have and how old I am. Then this is called a decision tree, right? So we are evaluating whether this one is true and false, but note we have a second decision tree in here. So once the first value has been, evaluates true, then we go into a next question, all right? So let's see here. I am 17 years old and I have $39. Grace Wu, can you tell me how this evaluates if I'm 17 and I have $39?
It would be false because you have less than 4.
Okay, so let's walk through it, right? Age is 17. 17 is greater than 14. We're halfway there. That's true. Okay, but my money is 39. And is it equal to 40? No, that is false. And I don't get a cat. Okay, Boolean values are a type of information, so they can also be evaluated in a Boolean expression using logical operators. Okay, logical operators are the double and sign means and, or double ampersand. Those are technically called ampersands, not the General Mills symbol. I thought that when I was a little kid. So two ands means and. Two bold vertical lines means or. Exclamation point means not. Okay, the good way to remember not is when it's exclamation point and equals. It is not equals. Okay, so and, or, and not. All right. True and false. How do you think this evaluates? Joseph Bloomfield, what do you think true and false evaluates to in our computer world? You're totally safe because we've never touched on this before.
I would think that it would equate to false.
All right, let's see if you're thinking correctly. False, you are a winner. Great job. Why did you think that true and false would evaluate to false?
I just like took math and I was like a negative times the positive is a negative.
Okay, that's a great way to think about it. Okay, I think the way I've been thinking about it is just that idea is, can a statement be true and false at the same time? I guess I don't lie fits that one, but typically no. A statement cannot be true and false at the same time. Okay? A question, can a statement be true or false? Anyone have that answer? Can a statement be true or false? All right, I better hurry. We're running out of time. Okay, true is now going to be dark blue. False is going to be light blue. Okay, so here we are. These are called truth tables used in evaluating Boolean expressions. Okay, so true and true evaluates to true. That makes sense. True and false evaluates to true. We could use our same logic, positive and negative number. You multiply them, they get negative. Same thing with false and true. Positive and a negative number, you multiply them, you're going to get a negative. This is, in my mind, I think of it as, can a question be true and false, or false and true? No, that is false. False and false. This equilibrates to false, and this is because Both must be true for the Boolean expression to evaluate as true. Okay, so this is saying anything that is not true and true will evaluate to false, right? Both must be true for the Boolean expression to evaluate to true. All right, now this is, we are going to be using the or, true or true. What do we think that evaluates to? You can put it in the chat. True or true? Anyone have a feeling? True. Okay, that is correct. True or false? Oh. True or false evaluates to true. And this is, again, it's because of that either or. I find the thinking in this difficult. False and true, what would this evaluate to? If true and false evaluated to true? True, Nicole says. Brilliant. False and false or false evaluates to what? We're thinking false. They all seem false. Okay. So that is different than if we are just looking, well, I'd have to go all the way back up. But so false or false is false because it's false. Either may be true for the Boolean expression to evaluate to true in an or situation. Either of those may be true. When we use the not true evaluates to Ana Solis Garcia de Paradas. Anna? Not true evaluates to what? Oh, Seth, have no problem. I totally understand. False. Not true. So not false evaluates to. Nicole, help me out. Hang on, I'm just going to say, Seth, you're fine. We are basically at the end. If you need, you can lie down. He just had some Benadryl and it puts you right to sleep. Okay, so that's false. That's false. Oh, this is the last thing. Use logical operators to combine several Boolean expressions into one expression. Can I adopt a cat? I can if I have $40. All right. So this is the idea that we could say money equals $40 and age is greater than 14 is going to evaluate as true. I can adopt a cat. All right. So let's try this. 15 and 40. Taylor Branch, can you run this if we're saying I'm 15 years old and I have $40?
True.
True. And just so what happens is money's 40, money equals 40, that's correct. Age 15, greater than 14. I get a cat. So exciting. Okay, this is the tricky part. Once you have the true trues, both sides are true, or if one side is true and one side is false, how do we evaluate that? True and true, we said is true, as long as they are both true. If this was true, so true and true evaluates to true. So I get the cat. Okay, now it's your turn to make a flow chart. You can use the decision tree from before, or we can just talk this out. So someone's going to walk me through this. You're going to write down the variables in the boxes at the top. Inside the diamond shape, create the Boolean expression that will be used to make the decision. Draw true, false lines. The challenge is use logical operators and or not in your Boolean expression. Add extra branches. All right. Somebody's going to help me here. Colin Chiduri, are you out there? Colin? No. How about Jessie Lynn?
Can you
Jessie?
repeat the question for me?
Okay, no, this is a little tricky. The question is, what were the two pieces of information you wanted to have to make your choice for how you were going to dress from the start of this lesson?
What type of event it is and the dress code?
Okay, well, look at that. I already knew that. That was exactly what the last person had. Okay, so I'm saying my one variable is going to be type of event, and the other variable is going to be the dress code. So I don't know how to do this with not. And or how would we incorporate and or not in our Boolean expression? Oh, I know. Okay, so what I was saying here, for the type of event, I'm saying there are basically three choices. There is formal, informal, and business casual. Oh, hang on. I'm just going to try and type on this. No, I'm not interested. So I wanted type of event and dress code equals formal, is my thought. Does that make sense to everybody? Hang on, I need to be sharing, sorry. Present, and then I can show you my masterwork. Okay, so what I'm saying here is, I could only get my mouse where it belongs, type of event and dress code equals formal. So if my type of event is informal and my dress code is formal, can I decide what I'm going to wear? Anyone? So type of event is formal and dress code, or I have type of event is informal and dress code is formal, does not equal formal, right? I have two different ones. So that would be, I can't make my decision. If I change this, if I change my type of event to formal and the dress code was formal, what would my decision be? Or what would I be able to make my decision? The idea is yes, that it would be type of event is formal and dress code is formal. Formal and formal equals formal. I don't think that's technically accurate, but these are a little tricky. The easier one was the idea of, is it going to rain and what am I supposed to wear? So it's either yes, it's going to rain, or no, and then what you're going to wear. Okay? All right, so we are in the summary. We are key takeaways. 10, a Boolean value is a data type that is either true or false. 10 is less than 2, evaluates to false. Comparison operators are greater than or less than, greater than, less than or equal to, greater than or equal to, equals, and not equal to. Those all indicate a Boolean expression. 4 equals 4 evaluates to true. I don't know why that second number 4 is on a different color. Each side of the Boolean expression is reduced to a single value before you can evaluate it. Single values are compared and result in a Boolean value, true or false. More key takeaways. Boolean expressions can also include logical operators and, or not. Don't worry about that equals there, it does not belong. Both sides of the logical operator are reduced to a single term, or to a single Boolean value. So true and false evaluates to false. True or false evaluates to true. It can be true or false. A truth table is used to evaluate the reduced Boolean expressions to a single Boolean value. A decision is made with the single Boolean term value. A flowchart illustrates the steps of making a decision with a Boolean expression. That is our decision tree. It is a flowchart illustrating the steps needed. Boolean values, true or false. Boolean expression evaluates to either true or false. 3 is less than 8 evaluates to true. Okay, we have got a little video here.
When programming, it is often necessary to establish whether something is true or false, so that a computer can make decisions about what actions are appropriate to take next. For example, when deciding whether or not to provide voter registration information, the computer must first determine if it is true that the person is old enough to vote. This is something that is done using what programmers call a Boolean expression. You can think of it like a yes or no question that the computer can evaluate. It's called a Boolean because it's named after the mathematician named George Boole, who made many discoveries related to working with binary true or false values. In the voter registration example, your Boolean expression might look like this. This asks, is the value stored in the variable age equal to 18? If it is, then the statement is true. Otherwise, the statement is false. Remember, the double equals is the equality operator. It asks if two things are equal or not. If you are using a single equal sign, you are using the assignment operator to set the value of a variable, which is something else entirely. In addition to the equality operator, we can ask questions about if one value is greater than or less than another value, and these are called comparison operators. If you saw the statement 3 less than 2 in math class, you'd think something was terribly wrong, but this is still not math class. In programming, you use the comparison operators to ask the computer a question, which it can answer true or false. So with this line, the computer sees you asking, is 3 less than 2? The answer in this case is no, or false. We can use a comparison operator in our voter registration example to make the program even more accurate. Because it's not just 18-year-olds who can vote, it's anyone whose age is 18 or older. So the questions you'd want the computer to evaluate should be, is the user's age greater than or equal to 18? Like this. Now that we can express the question, we can have the computer actually do something depending on whether the answer is true or false, such as displaying the registration info if true. We'll learn more about how to do that next.
Okay. We have made it to the best part of the day. So now we get to do our warm-up. Put it in the chat. What are you doing for the holidays? Put your name in. Oh, actually, I can see your name. Olivia's staying at home. I'm staying at home. Nothing, says Joseph. Staying at home. Ooh, Huraut's going skiing. Good job. Stay safe. I used to be a ski instructor, you know. Baking with my family. That sounds like fun. We're going to have a big Zoom family meeting. Sleeping. There's a great one. I need sleep too. Thinking clearly is very important. Ooh, going to New Hampshire. That sounds like fun. Again, I don't know if any of you have traveled during COVID, but it's a very different experience. Like, you're nervous about stopping. Okay. Oh, hang on. Somehow I lost my chat. There's my chat. Oh, my goodness. So yes, we have some students that are not in state. Anna says that she's in Panama and she's going to celebrate with family. I know one other student that's actually in China. So you have no idea where the people in your breakout room actually are. What am I looking forward to for my vacation? I'm looking forward to sleeping and eating and not having to grade homework every night, and Christmas and feeling good and getting things for my friends and family and just having a great time. Anybody else have any special holiday thoughts or wishes? Ooh, Dakota says going on a ski trip. That may be a wish. I don't know. I wish I was going on a ski trip. That's exciting. The good thing about skiing is it's all outdoors and pretty much everyone is socially distanced. So that'll be interesting. All right, we have 1 minute left. Anything else? Anyone have any questions? Has anybody not turned in their Unit 3 app? Please get me your Unit 3 apps. I'll give you till the end of today. I've got to get my grades in. That's my big thing. So everything's going in on Wednesday. They moved it from Tuesday to Wednesday. All right. Should be turning sometime soon. 2:39. 2:39. Let's see. Baking with the family, having a Zoom with my family. We're going to have a big Zoom before Christmas because no one can come. Boy, 2:39 seems to take a long time. Hey, we're done.
Thank you.
Thank you.
Thank you.
Okay,
Thank you.
come in if you have any
Thank you.
questions on Wednesday. Okay, Hurad, Peter, Daniel, questions?
No, thank you.
No worries. Thank you so much, Hurad. Great day. Daniel? Anything I can help you with? Daniel? Daniel?